let's get started. So, hello. We're here to talk to you guys about how to build a respirator. This respirator, we are going to be using P100 filters. You can get these off of Amazon. And the resulting respirator that we have tested, when we test it using a port account device, that respirator scores off the chart, something like 10,000, right? Yeah, so like normally to pass N99, you need a 500 score on, I'm not sure what the units are exactly. But with this device, we are seeing it pass at the, anywhere from 3,000 to 10,000, depending on the way the airs blow. So you need a different device to validate at a P100, but this is going to give you really good protection. But as I've always said, and as we always say throughout our documentation, anything you build that we're going to talk about today, you should get it tested and validated yourself. Anything you put together, this is not NIOSH certified. We're not even pretending that this is NIOSH certified. We are going to use NIOSH certified parts, but that does not mean that the final product that has been built is NIOSH certified. So I just want to make sure that we're all abundantly clear that if you build one of these things, good for you, but I cannot vouch for you that you're going to get as full of protection as you might like. So that out of the way. What we're going to do is we're going to build our most recent generation of respirator. So the first generation respirator actually is this guy. This guy, as you can see, we talked about this on stream last time, which we stream, once every 3 months, so I can understand you might not remember. On this guy, you can see there's no weather guard. It's attached to a belt. We're using straps to attach to the belt. And we have there's a proprietary connector here for the power. So everything about this, we realized we needed to adjust. There's even, if you look real close, you can see that there's hex. I don't know if you could zoom in on that. It's not worth rearranging everything. But there are hexagonal screws in here. We found that using square nuts instead of hexagonal nuts really helps. So there's a lot of just minor improvements on this device. As time went on, the one we developed on stream last time is this guy. And this guy we developed on stream, it's got the outage, all the outputs and inputs are coming through the same side. It's got a weather shield on it, but it is still this sort of clunky oblong shape. And what we're using inside is a germ guardian filter, so we could get to N95. We could not get to N99 or to N100. I think we got really close to N99, but I don't think we ever beat it. Or did we beat it?
We were very close to it, I think it was over. I think it reached it eventually.
It reached it eventually, right. But it was sort of, you want it to really far exceed N99. And N99 is not a standard NIOSH pays attention to. They have N95 and they have N100. N99 is just a really nice to have, but it's not anything that they want to see either of those two things, nothing in between. So this was a cool idea and it was a great iteration. But on that, when we did that, we also did this. This is a battery pack. We'll build this again. And this, this design we haven't touched or really changed. It still uses a strap in order to connect it to whatever mounting device you're going to use it to. So we might want to change this case going forward. But for the most part, we consider this part to be done. What we're going to build today is this box with a slight change. This box has the same, ports all on one side. It's very small. It's square. And as you're going to see, it's actually using two of these filters rather than one large square germ guardian filter. And these filters, though, they are much more resistant. They have a much higher resistance in them. And because they have a much higher resistance, we need a much stronger fan. So we're using a CUI 154 fan. That fan is going to pull a tremendous amount. It's going to require a tremendous amount of pull. One of the things I hope we're going to have a chance to do today is connect it to this guy to see how much current we're going to be able to pull out of the battery when we're running it. So you get a sense of how long the battery would last. So, yeah. So that's what we're looking to do today. In the end, we're going to attach it again to this. I just opened this. This is a 3M 6502, I believe, a 6502. When you are building your devices, you have to be very careful because this does not have what the CDC calls source control. Source control is where when you breathe out, like you don't contaminate the people around you. Right. So if you're using this device to be like protective against other people or for other people, that's not how a traditional PAPR works. Traditional PAPR is the wearer is being protected from the environment, not the environment from the wearer. So if you're in a COVID-19 type of situation and you need to worry about source control, This does not provide that. You would need another filter on top of this particular component. 3M does sell those. They sell them in packs of like 5 for $300, something like that. And then you could have full source control. We're not doing that today. If you are building this to protect yourself from the environment, like I said, so if you're immune compromised and you want to protect yourself from your environment, or if you are in a fire zone or a heavy pollution zone and you want to protect yourself from that, like if you ride bikes all the time and you want to protect yourself from car exhaust, that would be what this device could work for. The full bill of materials here, if you were to, like, when we were putting this together, the bill of materials is around $70, but we're not counting the cost of the prints because we've just been making so many prints. So I think if we were to look at the full cost of the bill of materials, it would be non-trivial, but you know, in the $100 range, because this thing is the chip is about $100, or sorry, this chip is about $10. The mask is about $10. The battery is about $20. The filters are about $10. And then all the rest of it, oh, and the fan is 10, 12, something like that. 25. Okay, so the fan is a very expensive component. And then, but like like I said, we weren't counting the printed parts and we weren't counting the gasket parts. So our math is probably a little off. But when we publish the whole thing, we're going to publish a bill of materials and what all this stuff costs. So, but these are all the parts that you're going to need. So I don't know if you can look through the overhead camera there. But these are going to be all the parts for the whole build, right? Including, we're going to mount this to a cute little shoulder strap thing, because I'm told that, you know, I don't know if you know this, but I'm not the youngest. And so I'm seeing that a lot of people are wearing these over the strap deals. So we're gonna mount it to that just to try to be, you know, stylish. I'm gonna pretend. But let's be real. If you're wearing one of these things, style is probably not where your head's at. So, yeah, but we thought we'd give it a shot, make it kind of convenient. So, having said all of that, I don't suppose there's any questions in the chat. If there's no questions in the chat, then I think I'll just get going. Do we have anybody watching in the chat? That'd be nice to know. I don't know if we can. No. So I'm gonna just put the battery pack together. So the battery pack is actually fairly straightforward. So first thing we're gonna do is just put the light panel on. So there's, I don't know if you can see here.
Hold on, let's switch cameras. Can we switch to the zoom in? There we go. Move back a little bit, Mark. Lower.
So I put the light pipe on right here. The focus isn't the best here. We go back here. I put the light pipe on right here. And then you can see this, we have the holes in here. We're just going to slot this directly in, and the light pipe is going to slide. There's actually a little groove for the light pipe. So I don't know if you guys can see that groove. It's a little tricky to do here. Let me pull this back out. Maybe go to this camera where you can see the little groove thing there. But there's a little groove that's been printed in there. And then that groove is going to go to the other side of this, which is going to light up when we put the battery in. So now we just need to put the washers on. So start with this washer here. We're just going to finger tighten it right now. We can obviously tighten it up with hex wrenches or whatever tightening mechanism we want to use. Speaking of which, I think there's a hex bolt over here. So, here we go. So this, if the hardest part about this whole thing is that I have a tricky time getting the bolt on there, then you know that we've succeeded, right? Because that's always really annoying, but if that's all that we have to do here. So now, this is in there, and then we put the top on, and so the top has this little guy here. So we just put these two together. That's it. So, and then inside of here, we'll just put in, do we have the pliers? I should probably have the pliers or forceps. Thank you, sir. So this is going to make things easier to do in here. Again, this is not the, so put that in there. before I tighten this, it occurs to me that maybe the right thing to do is to actually put the bolts in so that the board itself is not what's holding the things together, but it's actually the bolts holding things together. What do you think?
Go ahead.
This one?
No, tighten the nut first.
I took it out, so we do the bolts first.
Yeah, but you want to make sure everything.
No? So, is this the right size? Oh, I gotta gouge some stuff out. Gotta gouge out material.
The tiny ones.
Right, I was getting the tiny ones. So there's material in the way that needs to be poked out.
Okay.
Yeah, it's really it's tricky to see, but that's always one of the issues with 3D prints is that you got to make sure that you have no material in the way that's blocking your ability to screw stuff in. So okay, so with that material out of the way, let's. Oh man, this guy really does not want to go into this. Are we sure this is an M3? Yeah. Good times, good times. There we go. That side, got it. And then we'll put in our hex bolt, or sorry, a hex nut, and
Square nut.
that's square nut. You're right. Sorry. And we have made it. So once I've got all 4 of these screwed in, we will have fully built out the power system. Right. So that's actually pretty straightforward, right? We have 3 of these little hex guys to put together, and then 4 square nuts with their associated screws, and then we're good to go. So, yeah, so, I mean, it's been a long time, it's been a long journey, right? Like, we've been doing this for now 2 years, right? 2 years or so? And it's been a lot. Like, we've learned a lot, I think. What do you think, Daryl?
Oh yeah, definitely.
Like, if I could do it again, I think I would still do this. I think that I would try to figure out, first of all, of course, how to make sure we stream on time. That'd be nice. But second of all, I think, like, we spent a lot of time trying to work on a ventilator splitter. And that was a lot of fun, but it was also not necessarily the best use of our time, I think, in retrospect. Just because, and it was pointed out to me that the problem with ventilator splitter, I'm going to just go to another one because I don't know what's going on with that hole. The problem with the ventilator splitter is that then you need to have staff to be able to handle running a ventilator at the end of the day, right? And if you don't have that staff, then you're going to have a hard time. Wow, this does not want to go in. Maybe this print is just bad. What do you think? Which one? What do you want? This one? Yeah. Well, while Daryl is figuring that out, remember this is also a finished printed one, so it's we have an extra just in case. And 3D prints, as you guys may or may not know, sometimes can get a little fuzzy around the edges. You got it? Here we go. All right, cool. Thank you, sir.
This requires a little violence.
I'm always a little leery about using violence on a part that, you know, Patrick spent forever to put together. Right? Like, these are boards that are non-trivial to assemble. But I guess, you know, when you got to be violent, you got to be violent. There it is.
It's okay. I'm gonna probably make a change to this particular housing.
What are you
Make it
thinking?
Easier.
Easier how?
To assemble. Probably change the shape of it a little bit.
We have one last. Where'd it go? Right there, and then this goes in here, and I guess I've got to be violent. And then we will be done.
Don't forget the little washer and
Fair point. Fair point. We originally wanted this guy to be waterproof, and it is somewhat waterproof. But we would have to make sure that we would coat the board with some water-resistant coating to ensure that if water did get in there, it doesn't screw everything up. right? Because the other thing is that if you are using this as a PAPR, and you're using it in an environment where you can get spills, such as a hospital where somebody might bleed or vomit on you, or if you're in some other environment where there's rain, like if you're outside. In those environments, you want to make sure that you have protection to make sure that the device will still function. Of course, if you're fully splashed, like the device, of course, cannot work when it's submerged. Man, this guy does not want to get screwed on. There we go. I'm sure there's some very off-color jokes to be making about this right now. So, thank you, sir. So now instead of finger tightening, we'll just go ahead and actually tighten. And that will have to remain finger tight. We just watched Megamind recently, and so we'll have to tighten it. Put this in. Oh yeah, then we have to put the little cap on. You don't have to, but you know, it's nice. It looks good. So I don't know if you guys can see it. There is light that's leaking out, but it is pretty faded. Perhaps blue is not the best color. It's there. It's not showing up on camera. There you go. Yeah, you can see it in there. I guess we're going to have to make sure that we don't print this in dark material. It is pretty tricky to see. I see it when I hide my eyes from the light. Probably a bad analogy there. Okay, power supply, done. So now, let's build the actual box itself. So as you guys can tell, we're going to move at a pretty rapid clip here. And the real meat of this is going to be actually testing it. So first thing first is we got to put a spacer in. So once we figured this thing out, and by we I mean Daryl. Once Daryl figured this out, so you just saw I put those two things in here. This is good. This improved the efficiency of the fans by 20%.
Don't put the gasket in there. Tape it down.
Oh, tape it down. Thank you. But this improved the filter efficiency, the fan efficiency by 20%. Like we were getting 20% more power, 20% better battery life, I should say, because the fan output was directed into the 22 millimeter hole size that we actually needed, as opposed to this larger aperture, which we don't need.
Yeah, just cut thinner strips and just wrap them in.
All right. Like so.
All the way around the edges, and then put one in the middle.
Gotcha. So go all the way around and then put one in the middle where the crease is. So I don't know if anybody's actually watching on stream, does this seem like a reasonable thing? Like if this is something where if you were dealing with a forest fire or dealing with all of a sudden a massive pollution event, you know, this is going to be a fire year. Like would somebody be interested in building one of these things? Right? That's the question that we are all asking ourselves is this something that somebody else would want to build? If they had would people have the inclination to build one of these things? So if you're in the comments, put a comment one way or the other. Of course, we understand that there are people who are going to be like, nah, man, I don't want to build this thing. I don't want to live in a world where I have to worry about whether or not I have to look like Mad Max in order to make things work. I just really hope that we don't. I hope that we can live in a world where you are right, where we don't need to look like Mad Max for everything to work. I don't know. Do we have anybody who's on moderation or on stream so that we can see if anybody is reacting one way or the other? Might need to get that. I may need to get on that first, or before we go any further. We forgot a laptop. That's gonna hurt us. That's gonna hurt us. Maybe the moderator can be slacking us since we have a Slack set up. internally.
My laptop is on the other side of the camera. Don't want to reach over.
You can move. Yeah, you can go. Like nobody's gonna, you know.
Battery is really
Ah, there we go. All right, so now we've got this taped down. We'll put this guy on.
So there's two of these. They're not identical. One's
Oh.
smaller than the other. So,
Okay.
so double check it. See which one's smaller. Put it on top. And the smaller one is the second. So you want to take the larger one.
Okay, so I'm taking the larger one. And then the smaller one goes on this guy. I assume so. It sort of affords being placed on it.
You should see that it fits inside
In the groove.
groove.
It is, because groove is in the heart. Wow, what do we got going on there? That was exciting. All right, so now we put this guy into this part of the box. Just kidding, we're not done. So we're gonna put this guy in first. It's gonna go on the bottom. And so now we have this guy looking like this. I don't know if you can see that. We have the bottom gasket. This is a tight fit. By design, I imagine. And then we put in the gasket like so.
Look right here. There we go. Okay.
All right. And now I have the pre. This has been pre-set up, so I'm gonna put this guy. Put the what do you call it?
BNC.
The BNC connector. Thank you. Through there's a little groove in the print to allow that. And then once that's in, and then I put the.
Screw it in.
I will screw it in. I've been directed. As you guys can tell, this is actually the first time I've assembled one of these particular units. So we've I don't know if you guys saw the last few builds, but this assembly time is radically faster than it has been in the past. So now we got to put this guy in. We need to make sure that the fan part, the opening is facing up, which sounds silly, but there's a possibility that somebody could, I suppose, put it in wrong. And now we need to wrap the cord around and just drop this guy in like so.
Hook the back first underneath the ledge. There you go.
Okay, the back underneath the ledge. There's definitely pressure involved in making sure that everything all goes together.
Straight
All right,
forward.
and then there's actually a little set of divots in the back. And that's what I'm aiming for. So this might be a bad print. And I saw this because the print is a little warped on the bottom, so I don't know if you can see that. And that warping might be screwing us up. That's why I printed that other white one. And if you can see Daryl frantically fixing this. Yeah, so there's definitely a little bit of pressure involved here. And by pressure, I mean, when you're putting the thing together, like we need to make sure that there's seals all the way through, right? Like that's one of the ways that you maintain integrity. And that's one of the ways that you make sure that there aren't any air particles that aren't going through the filter somehow getting into the fan and coming into your air supply. And so that's why there's a gasket on the bottom. There's going to be a gasket on the top. There's going to be, so this gasket's going to go on the top of the fan. And then we're going to have this guy. So I'm going to show you guys, I have to pull these things out while Daryl's handling that. So I'm going to pop those out while he's doing that. Got it? So it requires a little bit of love and care to make it work. So there we go, popping supports out. And sometimes the supports come out clean, sometimes the supports do not. I find that the supports that are given as defaults on the Prusa prints are way too, they are way too close to the builds. And because they are so close, they can be really tricky to actually use. Yeah, thank you. Really tricky to actually get off. Ugh. Yeah, that's that one, and I think we're clean. All right. All right, so now we're clean. I don't know if you can see that there. Clean on the inside there with the supports. So we need the gasket, and the gasket is obviously placed in the right place because there are, or rather there's an opening, and so your opening should be right. And then once we've done that, then we can do this opening, and again it should be obviously over the right place. And now, remember in the last one we had a bottom panel? We don't have that anymore, which is very exciting. What we're going to do with these bottom screws is that's how we're going to use the mount points. What we're going to do here is this is how we screw in. We're going to screw in right here using these short guys and these square nuts. So
before you screw them in, put 4 square nuts in the square holes on the bottom.
okay,
No, the bottom of the plate that you just
in this one. Oh, thank you. So
the easiest way is that put in the square nuts, put screws in, and these are going to be the 20 millimeter screws.
big ones or the little ones?
The little ones.
All right. So there's a little bit of DFA, as I say, design for assembly. So I haven't heard that there's any kind of commentary going on, so I'm not. So if there's people who are asking questions, I apologize that I'm not responding. As you can see, I got my hands full. Are there questions popping up anywhere over there?
No, we're lightly.
So the small ones, yeah, you can screw those in for right now. Just very little, yeah,
Right.
and just to hold them in place.
All right, screwing in. Very little, no traffic. It is sad, but you know, I guess if you start an hour and a half late and you only stream once every 3 months, I don't think you can expect to develop a following. I think that's how it works in this business. I'm not entirely sure, but that's kind of what they tell me. You got to actually stream once a week for people to give a crap.
So take the 20 millimeter bolts, which are
The shorter ones?
Yes, and screw them all the way in.
All right. Well, I'm going to do the screw. I'm going to put them in and then tighten them all down at once. So, once we're done with this, we have a special surprise, which is me making even more of a jackass of myself by testing this thing. Because here's the thing, right? You got into all this trouble. You've made this device, and it's giving you all this filtered air, and you're digging it, right? You're digging life. But the problem is, can you actually do anything, or are you just going to sit there looking like you've got a Bane mask on, but not actually able to contribute or work anything, do anything in life? So the point that we wanted to come up with is, what is a good demonstration that we can have that if you're wearing this thing, you can still do stuff, right? Like that's how to put it? Like, we want it so that you can actually, be physically active while you're wearing this thing, because that's kind of the point, right? It's pushing air to your face, because if you're wearing a passive respirator, and at this point we all know that if you're wearing a passive respirator and you have a good seal, right? You have a good seal around your face, which can be really tricky to know that you've got. Like, there's definitely scientific ways to know that you've got a good seal on the face, but most of us don't have access to that kind of equipment. So while Daryl was testing it. Most of us don't have access to that kind of equipment. So the idea is like, if I have properly sealed this to my face, after 2 hours, I'm gonna have a massive headache. That's not gonna be great. So what can I do to actually enjoy myself and have a life while at the same time being in an environment where all of this is happening, right? So, yeah, I mean, we've all seen these post-apocalyptic movies where we have to, wear gas masks or whatever to go outside, and it all looks terrible. And the reality is, there's already been 1 million acres burned in California this year. Like, I don't know that we're gonna be able to get away from this reality. I just don't know that we are. It'd be nice if we could, but I don't know that we are. And so what we wanted to do is create a device that will allow us to actually go about living our daily lives while at the same time try to figure out a way to solve all the problems that are around us. So, here's where we are. So I'm gonna, so Daryl continues to tighten things up and get things going. How's it looking over there, man? Making sure the seal is good. So while he's doing that, I'm just gonna put these guys together here. It's really straightforward, right? You have a different thing here, but it actually has T on it. So do these have an orientation?
Yeah, there's marking up top. There's actual markings on the filter that says top.
What are those things?
These are P100 filters from Klein Tools. So you can actually get them off of Amazon. There's a variety of P100 masks that you can buy, and these are basically like $13 filters. Like these are the replacement filters. They say they last a month, and that's probably about right. So that's one of the other things we wanted to do is make sure that you can have an easily replaceable system here for this, so you can not have to worry about sealing and resealing all the time, but at the same time that you can replace things quickly. So that's one of the reasons why you lock down the filter box and the fan box, and make sure that the fan is in there very securely, which is what Daryl's doing right now. But then this thing right here, we could, like after this is assembled, you could imagine that this becomes just a component, right? Like I screw this in, I screw this out, and I just pop it in, pop it out. And I could replace this every month. So now that these screws are here, I'll take these out, and I'm just going to put this back on top, right? This is how we set this up. All right, so.
Take those screws off, and then we're going to use the long 30mm screws.
Right. So once these are all unscrewed, then let's put this together on here. Make sure that the openings all line up. Make sure that the openings all line up. Is this supposed to be, how is this supposed to go? Like so?
Yeah, this sits on top.
Okay.
Everything should line up
So
with the holes.
you may get this impression that this is a lip. This is important. This lip right here, this is the water lip. So if moisture comes this way, it gets caught by the lip and doesn't, if too much moisture comes in, then yes, obviously it's going to spill over. But this is going to be a way to make sure that you have a little bit of moisture doesn't go all the way through.
Weather guard also.
Oh, the weather guard is the same. Okay. So I'm going to do it this way because I need to figure out how to make this easier. So this is why we put those 4 screws in at the first place. And go sideways. So now I have my 4 screws in. And then I'm going to put this down. And once that's down, then I'm going to take this, put this down. Sorry, you can figure out which way it's ought to be. And I'm going to take this, put this down, again, figuring out which way it ought to be. And now hopefully the gaskets are going to help hold the screws in just a little bit.
We'll just make sure your logo is in the right direction.
Logo goes like this. And so I don't know if you got that view on the camera top there. So now we screw in. How do I know that I'm in the right spot? This is the DFA we have to be careful of. So there's definitely a change in the resistance there. So that feels like it's going there.
You should be able to just push it in.
So maybe it's not in the right place. There we go. All right. So. All right.
So because
Look at
there's
that.
a lip, because there's a lip, you should be able to tighten until the gasket piece is no longer. You can't see the gasket piece in between the plastic. Makes it a little bit easier to assemble and know when you've tightened it enough.
This is the yellow gasket is what he's talking about right in there. So if we tighten it up enough, should be good.
Yeah, as long as there's a little bit, as long as you feel the compression, that's the main point.
All right. Well, I feel some compression going on here. Now we're gonna have to test this one, obviously, because we just assembled it. But there we go. We are not done. That's awesome.
You put on the bracket.
We can put on the bracket. So now let's mount it onto our device. So this guy, this is where the straps are going to go. So we're going to put that facing down. We're going to put square nuts in here and put in our button heads, button head torques.
Is there missing nuts on it?
There might be. This is the first. So I bought a 10-pound roll of filament from Matter Hackers when they were having a sale on it, and this is the first print off of that 10-pound spool because it's the first time I got this far. We used to be printing all the time. Like my printer was never off, and then like as time has gone on and we've tightened up our design parameters. Now we're not printing anywhere near as much, but with, with 10 pounds, I should be totally fine for printing any of these things out for the nearest future.
Mark, what about the other side first?
Okay.
It's just easier if we're hanging rather than, yeah, that's good. There's already nut on this.
Perfect.
Yeah. So what you want to do is you want to put this this bracket on the top side closest to the spout, so that it hangs off of it as opposed to not hanging off of it.
Yes. So we want the spout facing up, right? So one of the things that we've talked about is how do we get this thing to be front facing, right? Because if I'm if I'm an immune compromised individual and I want to wear this in such a way that I want to sit down and not have it be on my back, what does that look like? So here we go. There's that. There's a nut that fell out of there. This is going to be what we put to bolt it on this side. And this is going to hold it in. There's a little bit of tension there holding this up. So now we're going to take our little sling on here, sling bag, and just slot this in here. Did we tell Daniel that we're streaming right now? Does he know?
I don't know.
Maybe we should start messaging people. I feel like he should be making more fun of me. All right, so here we go. There's this piece is now on. Now this is going to be a pretty casual mount. Like I'm not sure, like what we're going to do to test this is I was going to do some dancing. And so if I'm going to dance with this and it's wearing it as a sling back, it may not work as well as if I were to wear it as a backpack. I've been doing test dances with a backpack, not with a sling back. But, you know, you might as well give it a shot. This isn't about, this is about demonstrating the quality of the technology, not necessarily about preserving my dignity. So, kidding me? There we go. I lost my keys in the couch for like an hour and a half earlier today. That's why the stream is so late. And it just feels like one of those days. So if the hex bolt were to just sort of pop off right now, I'd be like, oh, that's you know, if the nut were to sort of pop off, I'd be like, yeah, that's about par for the course for the day. I feel like that's you know, about where we are right now.
Seems like this was easier to assemble.
Much easier, much easier. I mean, we're done, right? Normally we'd be here for another, you know, 3 hours. Well, I mean, there we go. Dropping stuff. We also have a couple of backpacks here too, which is how we mounted it last time. So we're done. Voila. We will have to do another mount for the battery. So I don't know if we want to, how we're going to put that on here.
We'll just leave it in the pouch here for
Oh,
now.
that's a good idea. So, is the pouch going to be compliant enough? Let's find out. Works. And then we've got our BNC cable connecting. And then let's do a few sort of less formal tests. Where what we're going to do, I'm going to unzip this a little bit, put some of the extra cableage in this pouch. And what we're going to do is I have a little wind meter, and we're going to do just a little informal test to compare this guy against our old one in terms of outputs. But there it is, right? So now if I want to wear it, right, so we have black versions of this thing, and we have this thing, and so like we have this blue and white version, I guess, for people who want to be blue and white. And I guess we'd want to have a cross strap like this if we were going to really be stable, but for the most part, it just feels like a sling bag. And I guess I could wear it on the other side, couldn't I? I've got to tell you, I'm not exactly a fan of sling bags, because I have a busted shoulder. It's one of those sort of injuries that gets accumulated over the years. But yeah, there we go. So this is a thing where I can wear the thing, and it seems to be totally reasonable. So if I wanted to connect it to, so we'll connect this to a hose, and then we'll connect the Y splitter to the end of the hose. And then we connect these pieces to the end of the Y splitter. This is the crudest possible set of attachment points that you could have. But here we are. These guys, they're you know, part of the STL, they're part of the print plans that we provide here. We attach, twist on, and then attach, twist on, roughly aligned, not 100%, but that's what it is. Then we attach, and we attach. Thank you, sir. So now, putting it on is a little trickier, obviously, because I have, so now I do this. Actually, how did I do that? Aha. Let's take this guy off, because I got the straps all confused. So this goes here. This guy goes on the bottom. How long was our last stream, Patrick?
Like an hour and a half.
Yeah, so now we're done. That took us like no time at all. Did you turn it off?
I can. Give me a second.
There we go. I now have air. So, is this the most stylish thing in the world? Absolutely not, right? I'm not going to win any sort of style awards here, but that isn't the point. Right? We tried to get some style brought into here, but really what we're trying to do is, can we create a P100 filter, P100 respirator? And the answer is yes, we totally can. So I'm going to take this off, and then I'm going to show you guys just some of the wind tests that we can do of this thing using the Kestrel wind monitor. Is it a perfect wind monitor? Absolutely not. Right? There's ways of measuring flow. What we found is that if we try to measure flow the way that we, excuse me, let me take this off. If we try to measure flow the way that you're supposed to, we have a device that we've been using to measure flow that we're using for ventilators, but it turns out that ventilators are not the right devices to compare to, because a ventilator is a low flow device, right? You don't want the person on the ventilator to be jumping. In fact, if they are jumping, it's kind of terrifying. So let's go this way. That'll work. We'll give this a try.
Yeah, you can tighten it down.
Yeah. Make it tight and good. There we go. In the words of KRS-One. So now let me do the comparison. So we have a couple of different boxes here, and we can attach each of the different boxes to a power supply and see how it goes. We can also test this old school one. We're going to use the same battery across all the tests just to make sure that the battery is the same for each unit. So now I have this guy. Could you grab me a piece of blue tubing, Daryl, please? We're going to try to be rigorous with this test, but like I said, we're not rigorous here. Like this is a back of the envelope test. Perfect. So we got a tube of length 3. We're going to go over here. I'm going to put the Kestrel wind meter. Let's mark off a distance. We'll use the battery as a distance. I'll move it back here so that the Kestrel is here to here, right? Not the best, but it'll work. So let's turn this on. See what we get in terms of flow. I'm turning it all the way up. So it's all the way up. The Kestrel is not on. Good times. Turn it on, you little punk. There we go. All right. So the Kestrel is measuring a max of 12.3 for this old guy. I don't know which camera I'm looking at. There we go, 12.3. Is that correct? Nope, just kidding. This one. 12.3 for this guy. All right, so let's turn this off. Let's do, I'm going to disconnect this. Thank you. And we need to, thanks. We'll use this guy, which has this, it's got its thing disconnected. Thank you, sir. You have to make sure that you use the same battery so that you have a rough idea, because the batteries have different amounts of power in them. And what you don't want to do is use a full battery and try to compare that to a dead battery. So let's, can I reset this guy? All right, well, let's give this a try. Pretty loud. I should probably read the owner's manual for the Kestrel. So it's saying, there it goes, So I have to make sure that it does a max. Now it's saying the max is 14.6. So, this camera? 14.6. So we've got quite a bit more, well, not quite a bit more flow, but we've got more flow coming out of this guy. But it is smaller, and so let's check the power out. Oh, you want to do that? Okay, so we'll check. The one we want to check here, you can see that this shroud is bigger than this shroud. So the question is there more air coming through because the shroud is there more air coming through because the shroud is more full? Yeah. This is feeling a little wonky in here. So, okay. So now we go back to this guy, go back to my rough estimate. Let's see if I need to make the Kestrel turn off. Is that turn it off? All right, well, let's give this a try. Let's see what it does. All right, so we have to make, if the max is bigger than 14.6, we'll be good. If the max is smaller than 14.6, we're gonna have a problem. Okay, so this is the part where it's really annoying and I need to read the manual, but it's basically saying 13.1, which isn't the max. But as soon as I move it out of the flow, it's going to drop. So I guess what I can do is try to do that in front of the camera. But it does look like the smaller shroud is limiting the flow. Not as badly as, like, going from the 120 to the 96. The 96 does have more power, but the increased resistance of the P100s, essentially all combined, you need a bigger shroud than what this was. And so this is a version of with the 120 fan, but using N100s and not P100s. Why does that matter? Because N100s, and we'll show you guys how to build this one next. Sorry. Oops. Daryl's just giving me the stink eye, and he should. I broke it. Not NIOSH certified. I want to be abundantly clear about that.
Well, this is why we're not building this way anymore, because this is the solid printed onto the. But we can reinforce it just to double check. Same with this.
This is also solid?
Yeah. It's built on as one plate.
Are you guys hearing that? So we used to have, if you guys remember the last build we had, or I don't think we did this in the last build, but we had that 3-part components that I put in to assemble for the funnel. We used to only do it as 2 parts, and the 2 parts were solid, and that meant that there would be a lot of strain throughout the whole system. Okay, so now we're going to do a 120. I'm going to get this going. Going up to full. Put this out of the way. 11.3, 11.4. Yeah, so this flow is not as good as that flow, but that's actually to be expected because the Germ Guardian filter has a lot less resistance than the N100s. I think that's what we're seeing here. So this is an 11.5. And all of those units are in miles per hour. I might sneeze. I might not. So what we have now is basically a sense that this guy is going to give us our maximum flow for what we're trying to do. Now, I don't know if we can zoom in and see what happens when we plug this into the power supply, so we can get a sense of the amperage. Let me try to do that. Let me take this assembly out of the way So these are just some basic tests that we're doing to demonstrate the differences of the different models that we have and the different, of the different fan sizes. Because these are all design decisions that you have to make when you are trying to build these types of systems. Is how big of a fan should it be? How much resistance should I have? Et cetera, et cetera. So let's see. I'm probably going to screw this up.
Yeah.
Do we have where the connectors are?
Let's pull those wires.
These guys?
Mm-hmm. Let's get, oh no, get to the other end of that.
This guy? All right, so this will go into,
US or BNC.
I need a BNC.
It'll go to the battery block.
Right.
Take the battery out.
So what we're going to check for is, I need the BNC, please. What we're going to check for here is this is a this has a 3 milliamp hour 3000 milliamp hour battery, and so how many amps does it require to run this thing at full speed? And that will give us a sense of how long the battery will last if we know the amperage. So Patrick is setting everything to 12 volts, I guess. That's a 12 volt battery, so. All right, so we're good. I'll move out of the way so you guys can get a view of the display. It's not fall over. That's a good plan. So I'm moving it all the way up. So this has been moved all the way up. We have 1.3. So this device would last 2.5 hours on one of these guys. Not the best battery life. If I move it down to halfway, so now it is just before shut off. Just before shut off, I have 0.4. Oh no, is it going down? It's figuring itself out.
About 0.4.
It's about 0.4. So let's call it 0.4. So, 7 hours? Ish. So somewhere between 7 and 3.5, depending on how much physical activity you're doing. If you can keep it at 1, like it's a pretty good flow. So let's compare this to another unit. So if we compare it to the choke down unit that had a smaller flow, that would be, well, I can't use that guy. That'll be this guy. I mean, actually, I can use this guy because we don't care about the output. We care only about the use. Even though it's got a broken output, that does not affect this particular test. Or shouldn't. So we go all the way up. Same amperage on the top side. And if I go halfway, or if I go back to just before click off, .5.
Should be around the same, exact same fan.
It's the exact same fan, but it's got more resistance. So, I don't know.
The amperage should be the same, but the amount of flow is going to be different.
The amperage should be the same, and yet it is 0.5 and not 0.4. Oh, just kidding, it bounced down. Why so unstable?
Fan's trying to find a happy medium.
Fan's trying to find a happy medium. So, okay. So we'll turn this off. Now let's compare it to the 120. So the 120, this 120 had the lowest output of the entire set, right? At 11.5. Now, does this board work properly, actually? That's a good question. Has this board been fit for the 120? Because the firmware has to change, right?
Well, the firmware is just setting the minimum value, which on the previous ones were probably a little low.
Okay.
So we'll have to see.
All right,
Just, you might have to dial it into the low point.
all right, so we'll turn it all the way up to the top first. So 0.4 at the highest, right?
That's full blast.
Yeah.
It's full blast. And then, and remember that was giving us 11 and a half, whereas the biggest one was giving us 14 and a half. So, you know, you can work out the percentage differences, but I mean, basically what, 20, 30% better flow? But the battery life is enormously better. And if I bring this down to just before turning it off, still about 0.4. I mean, it's 0.39 versus 0.44. So if you were to wear this one, you could just let it go full blast and like you might save like a little bit of battery life. But if you're wearing this guy, you're going to want to pull it back entirely. I'm not sure if it's worth showing what this guy can do because the design is just so radically different. Anyway, so that's where we are. So I think we're going to take a pause on stream there, and then we're going to switch into actually testing this guy. So thank you very much for everybody who's been watching. Appreciate it. Now we should stop streaming? No?